Hello students, we are at AriserTalent and I'm your chemistry teacher. So, how are you all? I hope you are doing absolutely well. So, we are on the first chapter of our class 10th chemistry, that is chemical reactions and equations, and until now we have discussed about the lot of the terms in this chapter, that is several type of reactions in this chapter. So, in our previous lecture we have learned about oxidation. So, what basically the oxidation is? Oxidation is the addition of the oxygen. It means addition of any electronegative element. It is the removal of hydrogen, that is removal of any electropositive element, and the reactions in which oxidation and reduction takes place simultaneously are known as redox reactions. So our today's topic is reduction reactions. So our next topic is reduction reaction. So what basically happens in case of the reduction? Reduction may occur only when there is a 4 cases in this series. So reduction may occur when what will happen? Our first case is addition of hydrogen. Second case, removal of oxygen. In the third case, addition of electropositive element. And next, removal of electronegative element. So these are the basic 4 cases in which the reduction may occur. So firstly, the reduction may occur when there is an addition of hydrogen. It means hydrogen is added to a compound. There will be a removal of oxygen. Third case is addition of electropositive element. And the last case is removal of electronegative element. So these are the basic 4 cases in which the reduction may occur. So now we will deal with all these cases with the help of the examples. So in the first category, we will deal with addition of hydrogen. So our first topic is addition of hydrogen. So reduction basically occurs when there is an addition of hydrogen in a compound. We can consider many cases of the addition of the hydrogen. So we have our first example, H2 plus Cl2 gives 2HCl. So look at here, in Cl2, H2 is added. It means hydrogen is added to give the hydrochloric acid. So the addition of hydrogen is termed as reduction. Now we have our second example, H2 plus S. Hydrogen react with sulfur to give hydrogen sulfide. Our third example is C2H4 plus H2. This is C2H4. This is a compound of alkene series in which the hydrogen is added, and what we will get? We will get C2H6. Our next compound is Si plus H2. What we will get? We will get SiH2. So in all the 4 cases, what you can see here, the hydrogen is added in a element. Addition of hydrogen, and again addition of hydrogen. So the addition of the hydrogen in a particular type of reaction is termed as reduction. So these are the basic examples for addition of hydrogen. Now we will proceed to our next category. There will be a removal of oxygen from the compound. So our second topic is removal of oxygen. There will be a removal of oxygen from the compound. Now, what happens in the case of the removal of oxygen? If I take a particular element or compound, we will evolve out or we will take out the oxygen from it. This can be understood with the help of an example. So the example we have is, suppose we have C, that is carbon, water, and it will give CO plus H2. So what happened in this case? This is known as steam water and this is known as water gas. This is steam water, or we can say it as a coke gas, and this is water gas. We can also call it as a coke gas. So what we have seen in this example here, we have provided with a coke gas and we are obtaining the water gas in the right hand side of the equation. This is the formula for water gas. See here, H2O is present with oxygen and oxygen is removed, and in the RHS side we will get hydrogen. It means there is a removal of oxygen in this equation. Here we can write there is a removal of oxygen, and removal of oxygen is termed as reduction reaction. So you can clearly see here the oxygen is removed from the substance, and in the right hand side of the equation what we will get? We will get only H2. So this is the example for the removal of oxygen. Firstly, you can copy it. Then we will proceed to our third topic, that is addition of electropositive element. Now, our third category is addition of electropositive element. Addition of electropositive element is done, then we can consider it in the category of the reduction. We have dealt with these two topics. Now we are on our third category, addition of the electropositive element. So what happens in the case of electropositive element? Electropositive element is added to the compound. If I consider the example Cl2 and I am adding Hg to it, I will get HgCl2. If I am considering another example, that is Cl2 plus Mg, I will get MgCl2. So what happens in these two cases? See here, Hg is a symbol for mercury, and Mg is a symbol for magnesium, and in both the cases what we have seen here, an electropositive element is going to add in the reaction. These two are electropositive elements. So addition of electropositive element is counted in the category of reduction reaction. So this is all about the addition of electropositive element. Now we are on our last category of the chemical reaction, that is removal of electronegative element. So our fourth category is removal of electronegative element. Now, what do you mean by the removal of electronegative element? If a particular reaction is written, then the electronegative element will be removed from it to accomplish the particular reaction. So, if there happens the removal of electronegative element, we can count it in the category of the reduction reactions. So, what will happen here? I am considering ZnCl. ZnCl is zinc chloride, and what we have done, we have done Cl2 to it. So, zinc chloride is a particular compound here, and what we have seen here, if it is decomposed, the chlorine is liberated out. It means there is a removal of electronegative element. And again, in the case of ferrous sulfide, what we have observed here, it disassociates into iron and sulfur. So, sulfur being electronegative has been removed from the reaction. So, if the removal of electronegative element occur, these two are electronegative element, and if the removal of electronegative element occur, we can say that the reactions are termed as the reduction reaction. So, what we have discussed in the reduction reaction, there is a addition of hydrogen or electropositive element, and there is a removal of electronegative element, or we can say that oxygen, because oxygen is considered as an electronegative. So, it is all about the reduction reaction. You can copy it. Now, we will proceed to our next topic. Now, as we have already discussed that the reactions in which oxidation and reduction takes place simultaneously are known as redox reactions. We are coming back to our topic, and our topic was the last reactions of the chapter, that is redox reactions. So, the redox reactions, as the name indicates, it is formed of the two letters, that is Red and OX. So, I have already told you it comprises of two words, Red plus OX. So, Red basically means reduction and OX means oxidation. So, the reactions in which oxidation and reduction takes place simultaneously are counted in the category of redox reactions. So, here we have a definition for redox reaction. The reactions in which oxidation and reduction takes place simultaneously are known as redox reactions. It means oxidation and reduction will take place simultaneously, and these two reactions will happen in a particular case. Now we will understand the redox reaction with the help of an best example. So this topic must be clear to you. So now we will understand the redox reaction with the help of an example. So it must be clear to you. Now we have an example for redox reaction. Suppose we have given copper oxide and we are reacting it with H2. What we will obtain in the product side, we will get Cu plus H2O. So this is the basic reaction to understand oxidation and reduction. Now what will happen in this case? We are provided with copper oxide. This is hydrogen. What we will get here? We will get here copper plus water. So this is the basic equation for redox reaction. Now we will understand this equation. See here, what will happen in this case? The copper loses the oxygen atom and reduced to Cu. It means hydrogen helps copper to reduce into Cu and lose its oxygen atom. So hydrogen will act as a reducing agent for copper. And what will happen here? Copper oxide loses its oxygen and it is gained by oxygen. It means copper helps hydrogen to combine with oxygen to form H2O. So copper helps in oxidation and H2 helps in reduction. It means in both the cases oxidation and reduction take place simultaneously. So we may call it as a redox reaction. Here we can understand it. CuO plus H2 gives Cu plus H2O. You can see here copper oxide loses oxygen and reduced to Cu. It means there is a removal of oxygen. Now what will happen in this case? Hydrogen gains oxygen and H2O is formed. So I can say here there is a addition of oxygen. So in the first case we have the removal of oxygen and in the second case we have an addition of oxygen. So removal of oxygen is termed as reduction and addition of oxygen is known as oxidation. So the reactions in which oxidation and reduction takes place simultaneously are categorized into the category of redox reaction. So this is the basic example to understand the redox reaction in which one element helps in oxidation and one element will help in the reduction and the reaction proceed in the particular direction, that is the forward direction here. Now we will learn about our more two terms in the redox reactions, that is oxidizing agent or reducing agent. But firstly we will understand it with the help of the same example. What will happen here? Copper oxide reduced to Cu and hydrogen will help the copper oxide to do this. So hydrogen acts as a reducing agent and copper oxide loses its oxygen and help the hydrogen to combine with oxygen to form water. So copper oxide acts as an oxidizing agent. So the substance which help in the oxidation is known as oxidizing agent and the substance which help in the reduction is known as the reducing agent, and the substance which get oxidized is known as oxidation agent and the substance which get reduced is known as the reducing agent. So we are with our new two terms, that is oxidizing agent and reducing agent. But firstly you can copy it from here. So we are with our new two terms, and the first term is oxidizing agent, and the second term is reducing agent. Now, what is oxidizing agent and what is reducing agent? I have told you earlier that the copper helps in the oxidation of hydrogen, and hydrogen combines with oxygen to form a water. So CuO act here as an oxidizing agent. So we have CuO and H2. So copper oxide will act as an oxidizing agent and H2 will act as an reducing agent. So from this example, I hope it is clear to you that what are oxidizing agent and what are reducing agent. Now we will write about the definitions of oxidizing and reducing agent. So we have our first category, oxidizing agent. Oxidizing agent is the substance or the element which help in carry out the oxidation reaction. So these are elements which help in oxidation. So the elements which help in oxidation are termed as oxidizing agent. Now we are on our second topic, that is what will be the another definition for the oxidizing agent. It means they will help in providing electronegative element to an atom and help in the removal of electropositive element. So the another definition for it is helps in addition of electronegative element and removal of electropositive element. And the last one is it helps in the addition of oxygen and helps in the removal of hydrogen. So our third point will be helps in addition of oxygen and removal of hydrogen. It means the oxidizing agent will itself get reduced to accomplish the reaction. Here I am saying that CuO is an oxidizing agent, but it itself get reduced. So if the element get reduced, we can call it as an oxidizing agent. If it is oxidized, here H2 is oxidized, so we can call it as a reducing agent. It will be the opposite of each other. Now, similar to the oxidizing agent, we also have the reducing agent. Reducing agent are the elements which help in the reduction. It helps in the addition of electropositive element and removal of electronegative element. And the last one, it helps in the addition of oxygen. It helps in the removal of oxygen and helps in the addition of hydrogen to it. So these points will be the contrary in case of the reducing agent. So now we have dealt with our two terms, that is oxidizing agent and reducing agent. Now we will learn a difference table which is very important from your exam point of view about the difference between oxidation and reduction. But firstly you can copy it from here. So our next topic is difference between oxidation and reduction. So we have our first category, that is oxidation here. And we have our second category, that is reduction. So we want to draw a difference table to distinguish between what is oxidation and what is reduction. So we will consider the basic points here. So our first point is, in this reaction there is a addition of oxygen. If there is an addition of oxygen in this kind of reaction, the first point of distinguish between reduction is there will be an addition of hydrogen. So I can write here, there will be the addition of hydrogen. Now, second point to distinguish between them will be addition of oxygen means addition of electronegative element. Addition of electronegative element. But in case of reduction, there will be the addition of electropositive element. So, second point here is addition of electropositive element. Now, the third point is there is an addition of oxygen. It means in oxidation there will be the removal of hydrogen. So, our third point is removal of hydrogen. But in case of reduction, there will be the removal of oxygen. So, our third point here will be removal of oxygen. Now, there is a removal of hydrogen. It means hydrogen is an electropositive element. So, there will be the removal of electropositive element. So, the fourth point is removal of electropositive element. In this case, there is a removal of oxygen. It means there will be the removal of electronegative element. So, our fourth point here is now our fifth point will be on the basis of gain or loss of the electron. So, the fifth point to distinguish between oxidation and reduction will be, in case of oxidation, there will be the complete loss of electron or ion, but in case of reduction, there will be the gain of the electron. So, our fifth point is there will be loss of electron or ion. But in case of reduction, there will be the gain of electron or ion. So this is a basic differentiation table to distinguish between oxidation and reduction, and this is quite simpler to learn the oxidation and reduction from this table, and this will be very important from your exam point of view also. So in this lecture we have completed our topic, that is redox reaction. Now this lecture is over for today. We will deal with many more reactions in our next session. Thank you so much and have a nice day.